Imagine a spacecraft capable not just of making one trip to Earth's orbit, but of making many flights, returning and taking off again, almost like a regular passenger airplane. The Space Shuttle became not just a machine, but a symbol of a new era, filled with grand plans and incredible technical challenges. It was a dream that long seemed unattainable, a seemingly impossible combination of technology, innovation, and human courage. But this dream came to life in metal and fire, and forever changed humanity's perception of spaceflight. Nevertheless, behind the shine and triumphs of the first successful missions lay mistakes and tragedies that, despite all efforts, ultimately led to severe consequences and serious trials for the entire program. The history of the Space Shuttle is not just about technology, but a profound story of human persistence, great achievements, and the high price sometimes paid for cosmic ambitions. The early 1970s marked a fierce struggle for leadership in space, a time when the space race between superpowers reached its peak. At that time, the United States faced a pressing question: how to maintain and strengthen its superiority while continuing to explore the stars. Until then, most space vehicles were disposable. Each mission entailed billion-dollar costs, and the craft inevitably remained in space or fell into the ocean. NASA began to consider creating a fundamentally new type of space transport, a reusable craft that would allow for significantly reduced costs and increased flight frequency, opening new opportunities for orbit exploration. Developing the shuttle became a true challenge for engineering and technical progress. Realizing the idea meant combining in one vehicle a powerful rocket booster, a maneuverable winged spacecraft, and landing on solid ground rather than water, as was the case with the Apollo capsules. It was a unique project embracing the boldest ideas and innovations. The shuttle was an incredibly complex and coordinated system. The actual winged orbiter, two massive solid rocket boosters, and a huge external fuel tank. All these components worked in a synchronized tandem. This project embodied a perfect technological breakthrough. For the first time in human history, a vessel was created capable of repeated atmospheric reentries and safe landings on an airstrip, almost like a regular airplane. The shuttle project generated numerous innovations, hundreds of new technologies, and became a powerful symbol of engineering might and U.S. national pride in the space competition of the 20th century. The first flight of the Space Shuttle Columbia, which took place in April 1981, was the real culmination of years of intense work, extensive research, testing, and the hopes of millions of people. For the first time in history, a reusable spacecraft proved that it could not only go into space, but also safely return to Earth, ready for the next flight. This breakthrough marked the beginning of a new era, whose scale and significance are hard to overstate. In the following years, shuttles literally transformed the concept of space missions. They were used simultaneously for placing satellites into orbit, repairing and servicing spacecraft in space, conducting complex scientific experiments, and constructing world-class orbital stations. Shuttle flights opened new horizons for humanity. The possibility of expanding human presence in space became more accessible, efficient, and economically justified. Joint missions with international partners, transportation of heavy cargo, testing new technologies. All this made the shuttle a versatile tool, a kind of multifunctional engineer operating at the interface of Earth and nearby orbit. An era of rise, impressive activity scale, and groundbreaking achievements. This best characterizes this period. The spacecraft became not just a means of transportation, but a true symbol of technical and human progress. However, achieving such heights came at too high a price. In 1986, an incredibly tragic event shocked the entire world and NASA in particular. The Shuttle Challenger exploded just 73 seconds after launch, taking the lives of all 7 astronauts on board. This disaster became a painful and bitter reminder of how treacherous and dangerous space can be, as well as how fragile even the most advanced technology sometimes is. Investigations revealed problems with the solid rocket booster seals, which failed to withstand low temperatures at launch. A violation of operating rules triggered the catastrophe. The recovery period after this tragedy stretched over many years. The shuttle program was halted. Experts conducted an in-depth analysis of the mistakes made and significantly revised safety standards to protect the lives of subsequent crews. However, a second serious blow occurred in 2003. During re-entry, the shuttle Columbia broke apart in the atmosphere, also claiming the lives of all 7 crew members. The cause was damage to the thermal protection shield sustained during launch, which unfortunately went unnoticed due to flaws in inspection and control. This second tragedy further undermined trust in the reusable vehicle program and forced a reevaluation not only of safety measures, but also of the very concept of reusable space transport. After the disasters, NASA and the entire space community made colossal efforts to improve the shuttle program. Despite this, over time, it became clear the technology embedded in shuttles more than 30 years ago was gradually becoming obsolete, and the risks associated with it were increasingly significant. Shuttles continued to perform critical missions, including the construction and maintenance of the International Space Station. But at the same time, new projects emerged offering more modern and efficient solutions for spaceflight. As a result, under strict budget constraints and the need to upgrade the fleet, the decision was made to retire the shuttle program. In 2011, the last flight of the spacecraft Atlantis took place, a majestic conclusion to an era that lasted nearly 3 decades and left an indelible mark on the history of space exploration. The shuttles exited the stage, yielding to new reusable rockets and next-generation manned vehicles, such as SpaceX's reusable rockets. However, the shuttle legacy is not limited to technical achievements. It is a profound lesson in courage and loss, an enormous contribution to the development of science and technology, and a powerful symbol of humanity's drive to push the boundaries of the possible and look into the infinite cosmos with unshakable hope. The history of the Space Shuttle is much more than a list of missions, launches, and landings. It is a true epic embodying engineering courage and bravery, demonstrating the delicate balance between grand ambitions and necessary safety, as well as emphasizing the cost of progress, the price paid first and foremost by people. Despite tragedies and losses, the shuttle expanded the boundaries of possible space exploration and passed on to future generations a colossal amount of valuable data, experience, and technical knowledge that are actively used and developed to this day. Modern projects aimed at lunar and planetary exploration already integrate lessons learned from the shuttle's history into new engineering solutions and technologies. The principle of reusability has become an integral part of modern technological progress, and the shuttle was the first to prove its effectiveness in practice. Its story serves as a powerful reminder that the path to the stars is never easy or direct, but it is through overcoming trials and adversity that humanity's strength matures and fortifies, ready to step beyond the horizon of the known and gaze fearlessly into the infinite cosmos.